As a warm-up to today's lecture, let's do a little dynamic method selection puzzle just to remind ourselves of how all of this works. So let's suppose we have two classes. We have here dog, which implements bark, and we have show dog, which extends dog and overrides the bark method. So here, basically, we see that every show dog is a dog, and every dog is an object. And remember that every single type out there is a subtype of object if it doesn't extend something else, okay? So what you're supposed to do now is, for each of these assignments in this code, decide if it causes a compile time error. And then, assuming that we get rid of those errors, consider for each call to bark, figure out, is it dog whose bark is called, show dog whose bark is called, or 3, a syntax error happens because of runtime type checking. And reminder, the rules actually are pretty simple, right? So if you started getting nervous about this and you're like, gosh, it feels like there's so many rules, you have to condense your rule set. And this is more or less the whole rule set. So we say that the compiler allows a memory box to hold any subtype. So in other words, if it's a list, it can hold A lists, S lists, or lists, or whatever else, as long as it's a subtype. The compiler allows calls when it thinks, is this line of code valid, the compiler? It does it based on the static type. And then finally, in the case that one of the non-static methods in your class is overridden, then it's going to be selected at runtime based on the dynamic type. That is the type of the actual object. So remember that every time you have a variable, it is really just a pointer to something else out there in space. And the dynamic type is whatever type this actual thing is, the thing that got created using new. Now, everything else that you might want to do is based on static type, and that includes overloaded methods. Though I'll note here there are no overloaded methods in this problem on the left. And if you want a little more practice with those, you can see the discussion worksheets or previous lecture. We had one little overloading trick. Okay? So think about this problem here, and I will be waiting for you to answer. Okay, let's go through each line of code here. So first we start with this top line. We say new show dog, Mortimer, Corgi, some parameters. And this produces a show dog. And so the question is, can we put a show dog in an object memory box? So here's the box. It can point at anything that's an object. So we ask ourselves the question, is a show dog an object? Yes, a show dog is an object, so this is allowed. We now try to take our object memory pointer, cast it as a show dog, and store that in the show dog box. So in this case, we say, okay, I'm the compiler. What's the static type of O2? It's object. What's the static type of show dog in parentheses in front of O2? That's show dog. And then the static type, obviously, of this whole thing is simply going to be show dog. So in that case, can we put a show dog in a show dog box? Well, of course. So this line runs just fine. Next, we do sdx.bark. Now in this case, we know that the actual thing that got made, here's Mortimer. Ruff, ruff, ruff. Whenever we do sdx.bark, we say first, the compiler says, do show dogs have a bark method? Yes, they do. Okay, so I will call the bark method. And in this case, since the show dog actually does override the bark method, the show dog method gets run. So it works fine, show dog.bark. Okay, next up. Now, let's try and cast our object as a dog. So the static type of O2 is object. The static type of dog in parentheses O2 is dog. So the compiler says, is a dog a dog? Yes. So it allows this. Now we do dx.bark. To decide whether or not this is allowed, the compiler says, yes, it is, because a dog has a bark. Okay, good. And then when we call the bark method, well, we go to the actual object and we say, in the hierarchy, like if we go to that, what is the dynamic type of Mortimer here? It's show dog. And so if show dog overrides bark, which it does, then we call bark. Okay, barking happens in a show dog way. Now we get here. So in this case, first we'll play compiler. If we do O2, what's the static type of O2? It's still object. What's the static type of dog in parentheses O2? That is dog. So the compiler says, can dogs bark? Yes. So we allow it. And then in this case, again, we use the dynamic type and show dog barks. Okay. Now one little thing I want to say about casting that's occasionally confusing, putting something in a type in parentheses, this casting operation does not have any lasting effect. It is only, you can think of it as a way to say, compiler, for this expression only, think of this as a dog. It doesn't somehow change the static type of O2. Sometimes, occasionally, a lab assistant or a TA or even I will sloppily say something like it changes the static type, but actually it doesn't change anything. It just says temporarily treat this like a dog for the purposes of type checking. That's it. Okay. All right, next up, we take O2. Great. Static type is object. Then the static type of this right-hand side is dog. And to decide whether or not this is allowed, we say, is a dog an object? This is actually a lot like our first line. Well, indeed, a dog is an object, so it's allowed to be placed in the object box, and that works. Next, we say O3.bark. Now, you're the compiler, and you have to think, can objects bark? You only use the static type to decide what is allowed. And so in this case, that line of code, it will fail, and that's a compiler error. So to summarize, there's only one compiler error. It's this last line. And in every single case where it barks successfully, it's always the show dog bark, okay, for here. So that's it for this little puzzle. And again, there are many more of these out there. So to summarize before we get going with today's lecture, I do want to mention one thing. For those of you taking the class at Berkeley who are going to take exams, you may find questions on old 61B exams, worksheets, or whatever else that consider, what if a subclass has variables that have the same name as a superclass? So for example, maybe the dog class has a size and the show dog class also has a size. Okay, another type of question. What if a subclass has a static method with the same signature as a superclass method? So maybe we have max dog in both dog and in show dog. Okay, that's another type of question you might ask. And I guess I'll mention briefly, for static methods, this does not count as overriding. Overriding only applies to non-static methods. Okay? Here's a couple of, both of these are kind of problems you might see. Now the good news is, these two practices are called hiding, and I will not teach them in this class. And the reason it's good news is, it's confusing. Okay, I decided not to teach this ever again in 61B, and I find it tedious. So first off, it's bad style. You should never write code that does this. There's no reason to do it. If you have done this, you have made your code bad, in my opinion. Like, as far as I know, there's literally no reason to do this, and I think it should be a syntax error, personally. So it's awful, no reason to do it, and I find that while the rules are simple, we only have to add a couple, maybe, I think we have to add just one more bullet point to the list of rules. I've just found that it's more trouble than it's worth. People find it very confusing, and last year I decided, nope, it's gone from 61B. But if you do want to learn it, if you want to know how this works, there is a tutorial where they talk about the rules for resolving hiding. But again, in my opinion, this should have been a syntax error. So if in any old problems you see that a subclass has variables with the same name as a superclass, ignore that problem, right? I mean, it's just not part of our curriculum. It's basically, why should I teach you how to resolve something that's a bad idea? Let's say this was a class on horse training. You know, I don't talk about, okay, the day where if you do manage to punch your horse to death, like here's how to bury it, right? That's just, it's not part of a good horsemanship class. Like, that's just, I don't know, not something I think we should be learning about. Okay, so that's it in terms of this extra bonus video. Let's get going with the real stuff.